Good evening, everyone, and welcome to day five, or should I say night five of National Astronomy Week 2025. And we are almost halfway through our marathon 9-day event. My name is Les Brand, and I'll be hosting this session. And I'm joined by astronomers from across the UK and indeed Spain. And we're hoping to share with you some wonders of the night sky that are visible this evening, fingers crossed with clear skies. We will also be popping over to take a look, hopefully a couple of times with the Royal Observatory Greenwich to see what they're showing tonight on their live stream. And stay tuned at the end at 8 o'clock when, after this live stream, we will have a talk by Jerry Stone on Is Pluto a Planet? So some interesting topics to discuss there. So National Astronomy Week, something that happens every few years to basically coincide with celestial events. And only 4 years ago, we had the Mars encounter, the close approach of Mars. And our theme for this year is chasing the moon. And during the week, you may have noticed, if you've had the chance, we have had some wonderful clear skies, that the moon has actually started to grow. It started off as a thin crescent on Saturday on our first session, and tonight, in fact, it's approaching first quarter. And by our final broadcast on Sunday, it'll be approaching a full moon with just over 90% illumination. Of course, the moon doesn't shine itself. It's merely the reflection of the sunlight that gives rise to those effects that we call phases. So you will have noticed also that the moon moves eastward each night, and it doesn't stay static in the sky. And at the moment, this particular time, it is pretty near, almost directly southwards. So we'll be taking a look at the moon, but as it's chasing the moon, it's also getting nearby some other bright objects that also move across the sky compared with the background stars. And these are, of course, some planets. And there are 5 planets that are sort of pretty visible to the naked eye, 4 of which we may be able to take a look at this evening, starting from over in the west, the bright planet Venus. It looks really bright in the southwest sky. Just below that, getting in the gloom now, but we hopefully will be able to see it, is Saturn. But as we move eastwards, the next, and relatively near the moon, the next brightest object is in fact the giant, the king of all planets, the largest of all planets, Jupiter, which is shining extremely brightly. Again, clouds around Jupiter reflecting the sunlight beautifully. And then go a little bit further east, and we arrive at another brightish object that is distinctly red. And this, of course, is the red planet Mars. So throughout this evening, we'll be hopefully taking a look at some of those objects, but spending a little bit of time on the moon as well. So, as I mentioned earlier, we are joined by other astronomers from across the UK and in Spain. And so it's now time to meet some of them. And I am going to ask Andy Devi, who's actually our astronomer in Spain, to tell us what he's looking at. I think it's Saturn, isn't it, Andy?
It is. I'm just going to share it now. Now, unfortunately, I've been tracking Saturn, but it's now only 6 degrees above my western horizon. So we're actually looking through over 100 miles of atmosphere thickness. You can see this definitely spherical. Now, at the moment, the rings are edge on, so I'm going to overexpose to see if you can see some of the rings, because the rings, there's a hint of them now that they actually running in a vertical line like that in my field of view. I did take a video about 45 minutes ago when it was about 10 degrees higher, which I may be able to run later. But I was quite keen to try and give you a live view, but I've also been keeping my fingers crossed that this one, the scene didn't go, and two, I didn't lose it behind my western horizon. But unfortunately, it's not a good time to be imaging any planet when it's close to the horizon. The higher that they are, the less atmospheric thickness we go through and the better the atmospheric seeing is. But at least you've seen Saturn, but not particularly impressive view because of the conditions. Okay, Les, I'll hand it back to
Yeah, no,
you.
thanks very much, Andy. And I guess um, the, the issue that we're seeing there, as you say, is it's so low down. I mean, you're in Spain, so you've probably got some pristine skies most of the time. It would be very difficult around any sort of major town or city to, even if you had a clear horizon, to see Saturn at this time, because not just the atmosphere but the light pollution as well, the gloom
Yeah.
that you get low
Well,
down. So
I think I'm 17 degrees further south. My latitude's 37 degrees north, so Saturn would not be visible from UK at the moment. Okay, I'll hand back.
yeah, okay, thanks, Andy. I mean, at least we've managed to see something that if you squint really hard, you could imagine that well, don't need to imagine it, it was in fact Saturn. And as astronomers, we do have lots of techniques that we can use from time to time to try and improve the quality of our images as well. So we might come on to a little bit more of that later on in our session. We've got a few minutes, I think, to take a look if David Arditi is currently pointing his telescope towards Venus, which is not that far from Saturn. So over to you, David.
Yes, indeed, Les. I have got a nice view of Venus. I am in Edgware, northwest London. It's actually cloudy here, but it's like a very thin, uniform layer of cloud across the whole sky, which is gradually evaporating. So I'm having to use a much longer exposure than usual to capture Venus. Normally, you'd capture it in 100th of a second or less, but actually I'm using half-second exposures to capture Venus. And there it is. It's a crescent phase. It is getting quite big. It would be big enough. The crescent phase is now just about be visible in good binoculars, if you can keep the binoculars steady. It's about 18 degrees high, and if it's not cloudy, then it's by far the brightest object in the sky. Venus, of course, is known as the evening star when it sets after the sun. It's always quite close to the sun in the sky because it is an inferior planet. Its orbit is within that of the Earth. So we're always looking in roughly the direction of the sun to see Venus and indeed Mercury. But Venus is close to what we call greatest eastern elongation at the moment, where it has swung out a reasonable distance from the sun, and it is setting several hours after the sun. And at other times of the year, we see Venus in the morning sky rising before the sun, and that's when Venus is the morning star, or phosphorus in Greek, and the evening star was Hesperus. We don't see much on Venus through a telescope directly because it has a very thick blanket of atmosphere. So we're looking at a brilliantly reflecting cloud deck made of droplets of sulfuric acid suspended in a dense carbon dioxide atmosphere. And of course, it's very hot on Venus. Underneath that, all that atmosphere, it's 400 degrees Celsius. And the pressure is extremely high, so it's a very unwelcome place. And the probes that we've sent down through the clouds of Venus have not worked for very long. So it's still very much a planet of mystery. There's some evidence of active volcanoes on Venus, and amateurs take part in these studies, and amateurs can actually do imaging of the night side of Venus in infrared these days, and can look at the surface and look for changes on the surface of Venus. But we're looking in visual light this evening at the cloud tops of Venus. And the slight false color there is due to our atmosphere refracting different colors differently. And Venus will be visible just for about a month more. It will be getting closer to the sun. It will be coming towards what we call inferior conjunction, which is when it's between the sun and the Earth. And then it's at its largest, but its phase is at its smallest. It doesn't actually pass in front of the sun. On this occasion, it's not transiting because it doesn't go it passes above or below the sun. It doesn't go that close. But we have a few weeks more to enjoy this really spectacular object in our evening skies.
Perfect. Perfect. Well, thank you so much, David, for sharing Venus with us and telling us a little bit about how inviting it is if we were ever to manage to stray a little bit too close to Venus.
I didn't
Yes.
say anything about the telescope. I was using a big telescope, a 14-inch Schmidt-Cassegrain telescope in my observatory in my back garden in the London suburbs.
Perfect. Perfect. Brilliant. Well, we'll be coming back to you and Andy in a short moment. But now let's just go and join with the Royal Observatory at Greenwich or Royal Observatory Greenwich because they should be at this moment in time looking at Jupiter, I believe. So a little talk.
Can see little white dots, and these are what they are. These are images taken by NASA over various different missions. And as well as that, I've just heard that we have just welcomed into our stream viewers of the official National Astronomy Week live stream. So hello, welcome to you all. Welcome to Tour the Night Sky Live with the Royal Observatory. My name is Jake, and we are all doing a little bit of stargazing together live here from Greenwich. But what we are looking at here are the 4 Galilean moons. From left to right, you have got Io, Europa, Ganymede, and Callisto, all rather interesting in their own right as well. Io is the most volcanically active place in the solar system, absolutely filled with volcanoes spewing matter out onto its surface, painting it a lovely mustardy yellow. We've got Europa there, possibly got a global ocean of water under its surface. Beside that, Ganymede, largest moon in the solar system, bigger even than the planet Mercury. And then on the far right-hand side, that is Callisto. Often known as an ugly duckling moon, it is absolutely covered in craters as it gets absolutely pelted by asteroids and other space rocks. Let's go back to the live view of Jupiter there. And as you can see here, we've got a bit of a brightened view of the moons there. You can see they're tiny little dots, but they were first discovered all the way back in the early 1600s by Galileo, hence they are known as the Galilean moons. In fact, the discovery of the Galilean moons was sort of pivotal in first discovering that the Earth is not the center of the universe, that other things orbit around other things other than the Earth. So there we have a beautiful view of Jupiter and its Galilean moons live from the Annie Maunder Astrographic Telescope right here in Greenwich in London. And this goes to show as well that even though we are in the middle of an enormous city, we can still see these beautiful objects, even with a bit of light pollution as well, because Jupiter is so bright, reflecting so much sunlight, it really does just push through that light pollution, so we really don't have to worry about it too much. So from here, we are going to take a look at our second target of the night. So we're going to continue touring the night sky to look at something a little bit different. So looking at our map of the night sky, we are going to move,
we can move back
across
from
to the left.
Royal Observatory Greenwich now. They've moved on from their live streaming. So unfortunately, we can't communicate with them because it's one directional. But I think we can now move over to James and Richard in Nottingham, who should be targeting the moon, I believe, James. Richard.
Yes, welcome from Nottingham. 4 degrees C here, so we're all wrapped up. We should have a picture coming of our all-sky camera at our observatory. You can see there the observatory on the left and the moon to the right of that. And if my mouse is visible, Venus is very close to the observatory. Jupiter's up by the moon, and Mars is over here by Castor and Pollux. Now we're going to go over to we've got 3 telescopes on the mount, and we've put cameras on all of them, but we're just going to look at 2 of them. This is a 120 millimeter refractor, and it's got a camera on it. And this is a live view of the moon. And we can see half. We're at the first quarter, so we can see half of the near side of the moon is illuminated. And you can see these big mare, which have been talked about earlier in the week. And the terminator is this line down the middle where day meets night. So if you're standing on the terminator on the moon, you would see the sun rising, and you'd go from being in the night to daytime. Now I'm going to change.
I guess, James, that over the period of maybe even a couple of hours, you might even be able to see some of those shadows changing a little bit on the terminator.
Oh, definitely. We were looking at Ptolemaeus earlier. Started out invisible, and now is fairly well illuminated. So we're going to change to a different. This is the Celestron C14 telescope, and I'm just going to whip up to the top of the moon.
So that's the same sort of telescope that David was using earlier for Venus, and I believe also the Royal Observatory Greenwich were using for their Jupiter.
Yeah. And looking at the other feeds tonight, it looks like there's fairly good seeing over the UK. And every time I see David Arditi's feeds, I'm amazed that in London he has such good seeing. So if I reach over to the right, it's because I'm altering the focus slightly with an electronic focuser. So this is the northern pole of the moon. Now, Les, does my pointer show up?
It does, yes, yeah, absolutely. I mean, perhaps you could tell us a little bit about what you're using there to actually get those remarkable images that we can see.
So the telescope is just a Celestron C14, and we've got an electronic focuser on the back of that. And then we've got a ZWO 585 color camera on there. We've got no Barlows, no ADCs or anything. This is just a live unadjusted image, and we're capturing this data in fire capture.
Mm-hmm.
But
so it's interesting. You said it's a color camera.
Yeah.
So this image is actually in color, but you can really see just how the color of the moon is in fact pretty sort of neutral in some respects.
Yeah.
But I know you can actually tease out some colors, or some people have a knack of being able to tease out some of the what we call the minerals, the mineralization on the moon.
Yeah, that's not something I've done, but yeah, some people do look at the different elements from the minerals on the surface of the moon. And as David was saying, the moon isn't emitting any of its own light. This is all reflected from the sun, and the light time from the moon to Earth is 1.2 seconds, whereas for David and Venus it was just over 4 minutes. So if something happens on the moon, it takes us a second or so to see there's a difference. So we can see the features. We've got rough craters, and then we've got much smoother areas. And these smoother areas are the mare, because people thought they were seas, although they're just seas of frozen lava or solid lava. And most of the craters we're seeing are from impact events. from the very distant past, 3 billion years or so ago or more. And here we can see this smooth area here is the northernmost sea, Mare Frigoris, or the Sea of Cold. And here we can see a scar running left to right. So north's at the top, east is on the right. So this scar is running east to west, and this is the Alpine Valley. And at the bottom of that is a very fine rill, a crease, looks like a river. What I'm going to do, I'm just using.
Do we know the scale of that, James?
It's long and wide. I haven't scribbled down the numbers for that, I'm afraid. So where's my picture? This is what I'm moving the telescope with. It's just a Skywatcher handset, and I'm just using these 4 buttons to move the telescope. Now what I'm doing, I'm moving a bit south, and here we can see there's a mountain range here called the Caucasus, and there's a crater here called Cassini. And what I can do is I can zoom into Cassini, make it a bit bigger, and then alter the focus a bit. And you can see Cassini's got a nice rim around the edge, and within the crater itself, although a lot of the body or the floor of the crater is smooth, there are 2 other craters inside, and they're named Cassini A and B, and obviously they're much younger than the Cassini crater proper. So I'll come back out.
And it also looked as though the if you like, the bottom of the Cassini crater seemed slightly higher in some respects than the surrounding area. Is that the case?
I'm not aware of that. There's an excellent bit of software online called QuickMap. It's a software package which runs on the internet, and you can, in fact, we've got it open. Can we, let me move it over here. Is this showing, Les?
Yes, it is.
So this is data from the Lunar Orbiter, and this is partially my cheat sheet because I've turned on the labeling, and here we can see Cassini, and there's Cassini A and B, and one of the tools in here is I can draw a line across Cassini, and it will give us a plot of the terrain here from my starting point to the end point. And there's a faint marker appearing over the crater, so we can see the floor of the Mare Imbrium is there, and then we go up. There's the rim of the crater, and here's the first part of the floor of the Cassini, and it looks to be pretty much the same level as Mare Imbrium. And then we go up again, another rim of the Cassini A, and then back down, and we've got some folded structures here, and then the final rim of Cassini.
So we certainly get a feel for the scale of, and in fact, I mean, the energy and the power of that secondary impact that must have happened, years after the main crater was formed. It's sort of really created height there. Yeah. Excellent. Carry
on. Here we go down. We've got the Sea of Serenity here, and this is a little, not a bridge, a valley between the Sea of Serenity and Mare Imbrium, and we leave the Caucasus Mountains and we join the Apennine Mountains. And again, hopefully I can zoom in here. And this is
If I
Yeah.
recall correctly, that's near the site of the landing site of Apollo 15.
Yes, you're stealing all my punchlines.
Oh, I'm sorry, James. We should have rehearsed
No.
more. We should have rehearsed more beforehand.
No, this is good. I'm glad you know your stuff. So yeah, we've got the Hadley Rill is around here. It's in shade at the moment, but that's the area, as you say, of Apollo 15. What we're also going to do is go a bit further down. So this is Mare Vaporum here, and you can. Oh, I've got my hand set the wrong way, I'm afraid. I'm going to zoom in to another structure. And autofocus again slightly. So this is the small crater in the center is Hyginus. And it's not a particularly big crater. It's about 9 kilometers in diameter. But we've also got this linear structure stretching out to the northwest and the southeast. And this is the Hyginus Rill. And the Hyginus crater is one of the few craters on the moon which isn't, or likely isn't, caused by an impact event. So have a guess. What do you think probably caused it?
Some sort of volcanic action.
Yeah. So I think that's the current thinking, that this is a volcanic structure and it's actually collapsed. And again, we could use QuickMap to do a line of a transect over it and look at the contours. And this rill in total is about 220 kilometers in length. What we could.
So now I think fairly close to that region there's something of particular interest, which is a trick of the light almost. Am I seeing it there? Just to the left of the rill?
Oh, I see what, yes, the Lunar V. Yeah, we can zoom into that. So that's one of these clair obscure features. So this is a feature which at certain illumination levels shows up something anthropomorphic or something interesting. And here we've got a V. It's not in the best phase for showing this V, but this is related to the crater Eucurt just here. And there are other structures. I'm hoping we're going to see one more as we go down.
Okay.
Head south.
So I think we'll take a look at the next object, the next feature. Let's see if we can tell what it is.
Now, interestingly, I'm going to zoom in here. I think Chris Hooker was talking about features on the moon with female names, and there being very few. Now, these two small craters are both named after females. Bruce, which is 6 kilometers in diameter, and Blagg from Mary Blagg, a smaller one at 5 kilometers in diameter. And these sit inside the Sinus Medi, the sort of the middle bay of the sun. And I think it's quite amazing that this is only 5 kilometers in diameter, but we're getting a reasonably good view of that from whatever our distance away is, quarter of a million miles. Is that right?
That's about right. About 385,000 kilometers on average is the mean distance, isn't it? I'm not quite sure exactly what it is at this moment in time, because of course the moon does orbit around the Earth in a elliptical orbit. So at some points it's a little bit closer, and other points in its orbit it's a little bit further away, of course.
Yeah, so, and that's when we get the supermoons that the papers and the media love.
Indeed.
So this lovely big circular crater with an off-centered internal craterlet. This is Ptolemaeus, and earlier tonight this was not visible. I've taken some images which I probably can't process tonight, but this was totally in darkness, in shadow, and now you can see it's becoming illuminated, and we can see these shadow features around the edge, which are from the eastern rim of the crater, obstructing the sun from hitting the crater full on. And the other crater we've got here is Albertanius, and this has got another one of those clair obscure features. And I'd better just zoom in. Not too much.
Maybe the clue there is two circles and something that might look like a nose, maybe?
Well, I think that's it. I think here there's meant to be a shadow which looks like the brow, the eye socket, nose, lips, and a chin. And it's meant to be a face. I'm not convinced, but people like looking for these things.
Exactly. Excellent, James. Well, James, I think that's been a marvelous tour of some of the features of the moon so far. But brilliantly clear and lovely images, and I think we need to move on for the moment, and maybe before the end of the evening we might be able to come back to you, but I think you might be turning your telescopes to Jupiter a bit later. So thanks so much for sharing that with us. And I think we will move on to back to Spain, actually. I think Andy will be showing us Mars. Andy.
Okay, I've got a live view of Mars there. I'll just take my cap off so I look a bit more presentable. I'm only using a 5-inch refractor telescope, so I've had to use a 5 times Barlow lens, which is really pushing it for the aperture of my instrument. And I'm using a Saturn M mono camera. So the only features that I can pick out are this is the northern polar ice cap. So obviously the image is inverted, but also if you look on the surface, you can see definite dark and light areas. I'm not particularly a planetary specialist, but I do from time to time enjoy imaging the planets. But such as David, that's got the 14-inch telescope, they can image at wide aperture at 5 and sometimes pushing it out to 10-meter focal length, which is it's a beautiful instrument specifically for planetary. But I'm not kitted out with one of those over here at Spain at the moment.
But no, nevertheless, Andy, what you're showing us there, although it does look maybe a little bit sort of fuzzy in the sense of a little bit of movement and so on.
That's the atmospheric seeing that. Yeah.
Exactly, yeah. And that, I mean, just to explain what we're talking about there, it's that the light from the planets, indeed the light from the stars, is coming through the Earth's atmosphere. And depending on the elevation, the height of the object that we're looking at, more or less of the atmosphere will be interacting, will be perturbing the light and causing it to wobble. And some folk characterize this as a sort of, the objects are like jelly, sort of just wobbling all over the place. But I think what's remarkable here, Andy, is it's a small refractor. It's a relatively small scope, and you're getting some images that you can see some of the details, if not beautifully clear.
Yeah, obviously, if I run say 2,000 or 3,000 frames in fire capture, I'm actually showing in sharp cap. I've got an older computer, and I want to be able to continue with my feed rather than suffer any computer failures. But talking about the atmosphere, there's like 4 levels within it. Obviously, the higher up, the less atmosphere that we look through. But normally that you get disturbance in the atmospheric scene in the first couple of meters due to ground temperature. And then when you go a level above that, it depends on if there are
I think your audio is just cutting out a little bit, Andy. So
which could be
there we go. Back in.
okay. I just got a warning up then, yeah, and I've got 300 gigs here at the moment, so I'll hand over, Les, anyway.
Okay, brilliant. Thank you very much, Andy, for sharing that. So that's sort of looking over the eastern part of the sky, and I think in a moment we were going to go back to James and Richard on Jupiter. I'd just sort of check in with them in if they've had time enough to sort of reset the scope from the moon to Jupiter.
Give us another minute or so.
Another minute or so. Okay, I'll tell you what we'll do. Just in the meantime, I will sort of very quickly share an image just to give an overall view of sort of what we've been talking about this evening, about where things are in the night sky. So this sort of image that we're seeing here is actually a rendition of the ground and the sky, and the ground is showing it as curved. It's just the way the rendition works. It's you know, we don't have a flat Earth, of course, and we have a sphere around us, which is the night sky. But we can see here very clearly in red, these lines represent the paths of the planets across the sky. So when you hear in the media about the great parade of planets, well, actually, very simply, they are all following a particular region in space known as the ecliptic. They are always aligned in this manner. Their relative positions might change a little bit. It just so happens at our current moment in time, Saturn is leading. In fact, below the horizon on this one is Mercury. That is another planet that is just about visible with the naked eye. You have to be very careful because it's very close to the sun. But as we mentioned earlier, Saturn, as even Neptune, we can't see Neptune with our naked eye. Venus, of course, we've seen it already this evening. But then they all follow this red line called the ecliptic. It is nothing more than that. But at the moment, we can see 4 Mars, Jupiter, Venus, and just about Saturn. In another week or two, I believe Mercury will be visible just after sunset. But Neptune, very faint, telescope only. And Uranus, very close to the moon today. But if you know where to look, really dark skies and excellent eyesight, you may be able to just about see it. But with the binoculars, yes, but it would show up as a sort of a very faint bluish object. So that's what we're talking about when we talk about the position, if you like, the parade of the planets. So I'm going to stop sharing that and see how we are with Richard and James. Are you okay for Jupiter?
Hello. Well, no, because we put it on Mars.
Ah, okay. Okie doke. That is fine. Okay, in which case, let's go to Mars. Please show us Mars.
Right then.
Yeah.
So let me just sort out focus. I never have any luck with Mars. Do you get the impression there that you've got a spherical body and there's dark and lighter patches?
I think the human brain is actually very good at merging the images. It sort of does that synthesis, and I can see it. There's a lot of the wobble, the jelly that I mentioned earlier, but there are some very distinct darker and lighter areas. And yeah, I think you've got a definite sort of circular image, you can tell it is a planet rather than a point object.
Yeah, and what we've got is there's a light sort of saucer shape top left, which is the northern polar cap. I hadn't prepared to talk about Mars. What else have we got? I think I'm struggling to see any detail.
Yeah, it would be a difficult one. I'm not sure that you'd be able to do a live stack on that as well using the tool that you've got there. Otherwise, we might be able to bring out some of that. So
I think the Valles Marinaris should be there, given the rotation. Mars rotates in a very similar time frame as Earth. Is it?
Yeah, that's right. It's about 24.5 hours roughly. So each day, if you looked at Mars successive days, it would have rotated a little bit compared with the previous day. Now, you mentioned Valles Marineris, of course, and that is a huge canyon effectively across the surface of Mars. Similar in some respects to the Grand Canyon in North America, but completely dwarfs it, doesn't it? It's about 4,000 kilometers long, and through telescopes you can just about make it out. Obviously, you'd need to do some cleaning up of this image.
Yeah, and unlike Venus and Jupiter, which are much bigger, their angular size is much greater, sort of 34 arc seconds. Mars is much smaller, which contributes to, I'm sure, the difficulty in viewing it live like this. I think it's probably only about 13 arc seconds.
Yeah, I think it's substantially sort of smaller across the sky than it was 4 years ago when we did the Mars encounter session.
And compared to the Moon, which is half a degree in diameter.
Indeed. Okay, great. Now I'm just seeing where we can move to next, because
we can try and go back to Jupiter. If you give us
would you like to do that in a few minutes? And in the meantime, let me just check in with David Arditi. David, are you you mentioned earlier on the Moon, on the Alpine Valley?
Apologies, no. I've moved off there now. I was looking for Jupiter, but I haven't, through this thin cloud, I haven't managed to find it, unfortunately. So I can't help you there. So you'll just have to talk amongst yourselves.
No, that's absolutely. This is what stargazing is all about. And whilst things can go extremely well, we've got the weather, we've got the telescopes to contend with, and we've got lots of clever tools to sort of help us move things around. But we need to be dynamic here. So I think what we'll do, whilst we're just waiting for James and Richard and David to get into position, let me just see if I can share another example. I was just showing you this a little bit earlier on, but if you were to actually see the night sky over a period of hours, you will notice that all of the stars appear to move, and that is because of the rotation of the Earth, of course, once every 24 hours, in contrast with Mars every 24.5 hours. So this is a little video I did only a couple of days ago. So the Moon is much lower down, much closer to Venus here, over in the western part of the sky. This is a wide angle lens, a 14mm focal lens. So completely at the other end of the scale of the scopes that the guys have been using tonight. But let me just run the video, and you will see amongst the clouds and the mist and the contrails from the jets and lots of other objects. But notice how the movement of the sky, and this is what our ancestors would have appreciated. They would have noticed the fixed stars at the back moving across the sky. We can see here a little sort of cluster of stars called Pleiades. There's Jupiter. Up there is Mars. We've got, of course, the wonderful constellation of Orion with the belt stars, and hanging down from the belt stars at the sword of Orion with a really massive cloud of nebulosity. But you'll also notice, I live on the outskirts of London, just how much light pollution there is, that unfortunately Mars, the view of the night sky low down, it's very bright. And that is the gloom that I was talking about when we're trying to look at objects so close to the horizon. So there we go. That is a view over about 6 hours, I think, that was tracking of the way the sky moves. So how are we doing, James? James has got Jupiter. So let's head over to Jupiter.
Right. We're just going to share the screen. So this is on the refractor. Is it showing up?
It is, yes.
So I'm going to zoom in. So this is a relatively wide field view. And hopefully you can see there's a bright disk in the center. And then if we really overexpose, you can see the 4 Galilean moons. I'm just getting my crib sheet to work out which are which. So Io, Europa, and Ganymede. And then Callisto's this one far out to the right. And what now, if we go to the Celestron C14, we can see clearly there. Again,
So this is a similar image to the one that we saw earlier with the Royal Observatory Greenwich, with the two moons just to one side. So yeah, fabulous.
Yeah, and I'll just see if I can get the focus a bit tighter. What I tend to do for focus with Jupiter is try and get the moons as small as possible. And we can see the belts are darker, and the zones are paler. There's no red spot. That's behind Jupiter tonight, unfortunately. I don't know what's happening for the rest of the week.
We don't normally have to wait too long, because Jupiter rotates very fast on its axis, isn't it? Just around about 10 hours for Jupiter.
Yeah, you can do a time-lapse animation of Jupiter's rotation over the course of one night in the winter. You can take images every 10 minutes or so and then stack them together and watch the planet rotate on its axis in a 10-hour period in a matter of seconds, and see the way the weather patterns change in the different bands of the planet.
Excellent. A wonderful image then. You can clearly see those cloud bands there, which incidentally, if anyone watching has a small telescope, point it towards Jupiter, get it into nice focus, and you will probably see 2 dark bands across the disk, and you are seeing those cloud bands there, and you'll probably see the 4 Galilean moons as well. So yeah, wonderful image. Thanks so much for getting the scope over to Jupiter there. I think because we're getting close to the top of the hour, I think what we'll do is just take a look at what David's excuse me, Strange has got. He has I think he's got cloudy skies at the moment, but just a day or so ago he managed to image what we call a deep sky object, a planetary nebula. So David, would you just like to Show us and tell us a little bit about what you've got.
Okay, so I was imaging from the Norman Lockyer Observatory. If I just whiz through these just a few secs. So can you see my screen?
Absolutely.
Yeah, so here we are, south coast of East Devon, founded by Sir Norman Lockyer in 1912, and in those days called the Hill Observatory. So that's an old picture of it as it was. Here's our planetarium, the Kensington and Maclean's just off the picture. We're home custodians of some fantastic historic telescopes, the Kensington, the Maclean, more recently the Mond Equatorial. We have a 20-inch reflector installed 2012, and just recently we were given the wonderful George Alcott binoculars that he used to discover 5 novae and 5 comets. Now normally we would be using this telescope. It's a 11-inch Celestron in a dome, but the dome's been leaking, so we're replacing out with the fiberglass dome. So I'm imaging from just down the road, about half a mile down the road, with a similar sized 10-inch telescope. And if I just, it's a Ritchie Chrétien, we'll just scroll on through some images. Here's a beauty of this telescope. It's get nice sharp pinpoint stars. Here's the fireworks galaxy. And just these are some pictures taken from the NLO on the Friday night by Alex Rowe. Just whiz through.
You just mentioned the fireworks galaxy there. I think it's attracted that name for a particular reason, hasn't it?
Yeah, there's been I think 9 supernovae here in the last probably 20, 30 years. So it's a spectacular object, most profligate galaxy for supernovae. Just flipping through some images we've taken from NLO. Wonderful picture of the Moon and Pleiades last night from Alex. Again, here we've got Neptune and Triton, Uranus, Saturn too low, Jupiter last night with a little red spot, which has now shrunk a lot. Mars a few nights ago, and then that was Mars last night, about 20 past 1. That's showing the boring face of Mars. Crater Lockyer was on view last night. What I want to talk about is some planetary nebulae. This is M46 with this little foreground object. Planetary nebula is, of course, a star that's reached the end of its life. And it's a foreground object on this lovely bright open cluster. Now, the best planetary nebula on view in the winter, of course, we get the Ring Nebula in the summer. This is the Eskimo Nebula, and you can pick up a lot of detail with this with a small telescope. It's a lovely sort of greeny blue color, bipolar planetary, and it's about 6,500 light years distance.
And how can you tell us how it got its name? I think it might be quite obvious, but again, our brains have to interpret these things.
Oh yeah, well you can see it obviously looks like an Eskimo wearing his parka. Sometimes called the Clown Face Nebula as well. But this is a likely demise of our sun in about 4,500 million years. So something we can look forward to. What else have we got here? Going further out of field, this is a cigar galaxy with the RC10 that was taken last night. This is a starburst galaxy, all this beautiful explosive material here, hydrogen alpha light. I'm using a filter on this telescope called a Octolong L Pro. Unfortunately, I'm imaging over the donkey sanctuary that have floodlights, so I have to cope with quite a bit of light pollution, but modern day filters cope with that quite well. The other thing to mention, of course, about M82, as was mentioned a few nights ago, a supernova that was discovered in 2014 by Steve Fossey. Now, nowadays, amateurs can use little diffraction grating called a star analyzer 100, and we can get spectra of these supernovae. And here in this spectra, you can see this dark absorption band, which is caused by silicon absorption. By taking a spectra, you can actually work out the blue shift from its rest wavelength and work out that this supernova shell is exploding at 12,000 kilometers per second. Remarkable for an object that's 12 million light years away. And by looking at the spectra of these objects, you can tell what type it is, either a thermonuclear supernova or a core collapse supernova. So by looking at these spectra, you can work out what it is. And here are a few supernovae from last night. These are all recently discovered. Most of these, of course, are discovered by robotic telescopes. This was discovered by Japanese observer Shinichi Ono back in December 2014. And you notice the name of these supernovas. You have the supernova, the year it's discovered. Then you go down the alphabetical list, A to Z. And once that's filled up, you go down another 26 numerals and so on. So at the end of 2024, you can actually see how many supernovae have been discovered in the year. And more recently, we've got two discovered just a few weeks ago by Atlas, which got the horrendous sounding name, the Asteroidal Terrestrial Impact Last Alert System. Now, this telescope images the night sky regularly on a nightly basis. I think there's telescopes in Hawaii and South Africa. So this is a Type 1A SN 2025 QE, and the night before they discovered 2025 OQ, these tiny little stars embedded on the galaxy.
Excellent, excellent. And of course, the light from those explosions for a brief moment, maybe several weeks, in fact, completely outshines the host galaxy. So absolutely remarkable images. Thanks very much, David, for sharing those. We've only got another couple of minutes before we finish our feed here. So I'm just thinking perhaps we could finish on a final live view of Jupiter. I think, James, you're still pointing in that direction, I hope.
Yes, we've just done a quick stack of some Jupiter data, and here it is. Got the northern equatorial zone. Where's the live feed? And there we are. There's the live view. We'll make it a bit bigger.
So what you're doing here is basically taking lots and lots of these images that we're seeing now, and then the computer's combining them together to basically improve the overall image.
Yeah. So break the video up into individual frames. It's filming here at 133 frames per second. So a 30-second exposure is several thousand frames. And it looks at each of the frames and gives them a quality rating. And then we can tell it we want to stack the best 50% of the frames, and it'll do that. And then we just tighten up the focus a bit with something called wavelets, and we get a live feed like the one on the left becomes something a bit better like the one on the right.
Brilliant.
It's not much better, but it's better.
It is indeed. It is indeed. So brilliant. Well, look, thank you very much, James. Really appreciate that. Thank you to Andy, to David, and James as well behind the scenes as well. To the two Davids, in fact. I think we've had a great session this evening. We managed to get over to the Royal Observatory Greenwich as well, and I'd like to thank people behind the scenes as well. We've got Callum, who's been amazing at making sure everybody's on screen at the right time, and other members of our sort of organization with Robin Scargill as well. So we're now coming up to, in fact, I think we've just gone to 8 o'clock. So we're going to be finishing our live stream session now, but please stay tuned, because coming up pretty much straight after I finish talking is Jerry Stone. And Jerry, well, just before I introduce Jerry, I do need to mention, of course, we've got another 4 evenings left to take us right into the weekend and Sunday. So please tune in again over the next few days for similar live streaming sessions from the UK and Spain. So, right, let us move into the second part of our evening, which is our talk by Jerry Stone. Jerry is the founder of Spaceflight UK. He's an expert in space flight. He's a freelance space presenter, and author and broadcaster, and an expert, as I say, on all sorts of space exploration, giving presentations on space right across the UK and abroad for many years. Tonight, he will be talking about something rather controversial, depending on which circles you move in recent astronomical history. I'm not going to steal too much of his thunder, but underneath my T-shirt, I do have a T-shirt with Pluto, and it will be remembered. I forgot to take it off, but Jerry is going to talk about the role of Pluto. Pluto, a very special object in our solar system, of course. And his talk is called, Is Pluto a Planet? So a big welcome to Jerry, and over to you.
Thanks very much. Let's just start this up. So I hope you can all see my test card there.
Coming through live.
Right, so here I am. So today I'm going to be looking at a very controversial event in recent astronomical history, when the role of Pluto was changed, and so was our solar system. So I'm going to pose and answer the question, is Pluto a planet? Now, I do need to make it clear that this is my most controversial presentation. In fact, it includes some material that one professional astronomer has told me I should not be saying. So on that basis, I feel I need to give you this warning. So looking up at the night sky, the ancient observers saw the patterns of the stars, and as they watched from night to night, the entire pattern shifted slightly, but the stars remained in the same positions relative to each other. But there were some points of light that changed position relative to the stars. They wandered around the sky, and so the ancient Greeks called them wanderers, except that they spoke Greek and not English, so they used the Greek word and called them planetal, from which we get the word planet. So there were originally there were 5 of these planets moving outward from the sun that could be seen from Earth with the naked eye, which were named after gods, or in one case a goddess. Mercury there, Venus, and then out past the Earth, Mars, Jupiter and Saturn. And that's how things were for many hundreds of years, until with the invention of the telescope we could see fainter objects. And in 1781, Sir William Herschel observed Uranus, leading to its discovery as a planet. It can actually be seen with the naked eye under the right conditions, and it had been. But because it's very faint and moves so slowly, it had not been recognised as a planet before. In fact, Herschel himself initially thought it was a comet. So what was the next planet to be discovered? Well, if I was in with a live audience, people put their hands up and many of them would say Neptune. Well, not Neptune. Now, the relative distances of the planets from the Sun were all well known, and there was a huge gap between Mars and Jupiter, and it seemed that there should be a planet in this place. So some astronomers started looking for it, and they referred to themselves as the Celestial Police. But despite their efforts, they were beaten by Giuseppe Piazzi, who discovered what he believed to be the missing planet on the very first day of the new century, 1st of January 1801, not 1800. It was named Ceres. What was not expected was that 14 months later, at a similar distance, another object was discovered and named Pallas. Then 2.5 years later, Juno, and another 2.5 years later, Vesta was found. And all of these were, at the time, listed in books and tables as planets. So including the Earth, this gave us a solar system with 11 planets. Well, with the discovery of even more objects, by 1845, it became obvious they could not all be planets in the accepted manner. So they were reclassified, and it was William Herschel who came up with the term asteroid, which means star-like, as that's how they appeared in a telescope, unlike the main planets, which showed as a disk. So we went from 11 planets down to 7. So this means we have actually downvoted planets in the past. And then in 1846, we did find a main planet, Neptune, on 23rd of September 1846, 60 years after the discovery of Uranus. Now, examination of the orbit of Uranus led to the opinion that a single body could not adequately explain its motion, and it was thought that perhaps 2 planets lay beyond Uranus. Further calculations led to a possible location, and a search was carried out to try and spot it. Physical search was carried out in America, and the astronomer assigned to the task was Clyde Tombaugh, seen here with his own telescope. He worked at the Lowell Observatory at Flagstaff, Arizona, and what made his search different was that he was not just using a telescope, but a telescope fitted with a camera. So photographs were taken on different dates of portions of the night sky and then of the same area a few days later. These would be developed and compared to see if anything had moved relative to the background stars. Today, this would be done by a computer, scanning the images and making comparisons to the various dots. But 95 years ago, this had to be done manually by visual examination. And it was done using a blink comparator, which would hold 2 images in the form of photographic plates 14 inches by 17 inches, and the user would check the same area of each, flipping between them, searching a quarter of the plates at a time, looking for something that appeared in one but was not in that position in the other. If you found something in another position in the second photo, it would be a good indication that this was the new object that was being sought. Well, on February 18th, 1930, Tombaugh was looking at 2 plates that had been taken on January 23rd and January 29th. Scanning back and forth between them, he discovers a faint spot here and here. Right. So this is Venetia Burney, who was born in 1918 and was 11 years old in March 1930. On March 14th, she was at her home in Oxford, having breakfast with her mother and her grandfather, Falconer Madden, who had been the librarian at the Bodleian Library at the University of Oxford. He was reading the Times, as people in Oxford do at breakfast, and on page 14 he read the great news and said he wondered what the new planet would be called. Well, Venetia knew about the Greek and Roman gods, and she knew the names of the existing planets, and said, why not call it Pluto? Her grandfather thought it was an excellent suggestion and passed the name to Herbert Hall Turner, who had been Astronomer Royal in the past and was a professor at Oxford. Turner sent a telegram to colleagues at the Lowell Observatory in America. Now, when I tell this story in schools, I explain that a telegram was an early form of text message. Anyway, they discussed it, and on the 1st of May, on the 13th of May, after a unanimous agreement to use the name, the news was announced and sent back to Venetia's grandfather, who passed it on to her. To say well done, he also gave her £5. Today, that would be worth around £400. He liked to be generous. As a result of the discovery, the solar system now consisted of the Sun and 9 planets, and the order of the planets could be remembered by making a mnemonic. You take the first letter of the name of each planet and construct a sentence of words that start with those letters. Of course, if you were a young space geek like me, then you already knew the order. My favourite was, my very educated mother just served up 9 planets. There are other versions. My very easy method just speeds up naming planets, or many vicious elephants munch jam sandwiches, unusually no peanuts. Or, seeing as we are near Valentine's Day, Mary's violet eyes make John sit up nights pining. Then there's one not to use in schools. Mary's virgin explanation made Joseph suspect upstairs neighbour Peter. But there's one that goes down very well in schools, especially in primary schools. My very energetic mouse jumped straight up Nanny's pants. But of course, this only works whilst there are 9 planets, and we don't have 9 planets anymore. In 2004, out beyond Pluto, we found something else, and another something else, and another, and another. So here are some familiar objects along with some of the new ones. The one I want you to notice in the bottom right is 2003 UB313. Now, of course, this isn't its name. It's a label which explains when it was discovered. But look at the size of it. This was reckoned to be bigger than Pluto. So it was obvious. If Pluto was a planet, then so was this. This would be the solar system's 10th planet. Well, we now believe they're almost identical in size, but the question still stands. If one is a planet, then surely the other one should be as well. And what about Sedna? Or the other objects? Are they planets or not? How can you tell? Well, you can only tell if we know what a planet actually is. It may seem odd, but until 2006, there was no official definition of a planet. Many of you will have come across astronomy books when you were young, which would tell that a planet is an object that orbits a star, but stars produce light, and planets can only be seen because they reflect the light of a star. But as I said, there was no official definition. So this became a topic for the International Astronomical Union, which is composed of over 13,000 professional astronomers from around the world. They have various meetings, but every 3 years there's a General Assembly which is held in a different country each time. In 2006, the General Assembly was held in Prague, and the subject of a planetary definition was discussed. So here's the original version of the solar system, and a new definition of a planet was put forward, leading to a new lineup, which included Ceres, the largest of the asteroids. I'll explain why in a moment. Pluto and its largest moon, Charon, and I'll explain that too. And of course, 2003 UB313. Now, Mike Brown, whose team discovered it, became quite fed up of having to repeat 2003 UB313 so many times before an official name was selected, so he decided to come up with a nickname, Xena. And yes, it was named after the warrior princess from the TV series. This is hardly surprising, as after all, astronomers do enjoy observing heavenly bodies. In fact, as I've said, all planets are named after gods or goddesses in the case of Venus, with one exception. We have the dullest name in the solar system. Literally, our name is mud. But actually, Earth is the wrong name. Over 70% of the surface is covered in water. A distant observer would see the blue part as being prominent rather than the brown part. So if you want to be scientifically accurate, we should name this planet Ocean. I don't think that's going to happen. Anyway, on 14th of September 2006, Xena was given the official name of Eris, after the goddess of discord, strife and disharmony. Considering the huge controversy it had produced, it was the perfect name. So we had a new solar system with 12 planets as a result of this draft definition of a planet. The initial proposal was intriguing. It had some interesting items. The definition read, a planet is a celestial body that is in orbit around a star and is not itself a star nor a satellite of a planet, and it has sufficient mass for its self-gravity to overcome rigid body forces so that it assumes a hydrostatic equilibrium that is a nearly round shape and has cleared the neighbourhood around its orbit. And it was decided if an object meets the first two criteria but not the third, it would be in a new classification of objects, a dwarf planet. This was on the basis that the small body would not have been able to have enough gravity to clear its orbit of other objects. But there are some issues with the wording of the definition. I mean, it may appear detailed, but actually it isn't a very good scientific definition. Let's start with the idea of a nearly round shape. How round is nearly? None of the planets are exactly round. Because of their rotation, their equatorial diameter is greater than their polar diameter. So how round should they be to qualify? Within 5%, 10%, 15.3%? And what about having cleared the neighbourhood around its orbit? Cleared by how much? 95%, 75%? And cleared of what? All objects greater than, say, 100 metres in diameter? And finally, cleared to what distance? 500,000 miles? 2.583 million? Again, These are all man-made limits. We need something defined to a much better degree. The question is, why wasn't it revised at the time? Well, actually, after further discussion during the Congress, a revised definition was produced, but only with a very small change in the text, though a major change in the meaning. Watch very carefully. In this version, the first criteria is that the object has to be in orbit around the Sun, not any star in general, specifically the Sun. That means that this is a definition just for planets in our solar system. Why? Because there may be planets that do not orbit any star and are just in free space. Really? I said. So how many of those are there? And at the time, the answer was 1, possibly. Currently, there are many more known examples and suspected examples. But I asked, why do we need a special definition for them? That would mean we'd need a definition for a relatively small number of objects, and also we need 3 definitions of planets. Planets that orbit our star, the Sun, planets that orbit other stars, a definition which has not yet been produced after nearly 20 years, planets that don't orbit any star, a definition which has also not been produced. Why not simply say is usually in orbit around a star, or even overwhelmingly found in orbit around a star? That would cover all of them. Do we really need a separate definition for a small class of objects? Do we need 3 definitions for stars? Stars in our galaxy, stars in other galaxies, stars not in any galaxy? Of course not. They're all stars. It doesn't matter where they are. Do we need 3 definitions for elephants? Elephants raised in Africa, elephants raised in India, elephants raised elsewhere? Of course not. They're all elephants. It doesn't matter where they are. Why should any object need a different definition depending on its location? Let's have a closer look at this, in particular the first section. A planet is a celestial body that is in orbit around the Sun and is not a star nor a satellite of a planet. A satellite of what? A planet. So that means a planet is a celestial body that is in orbit around the Sun and is not a star nor a satellite of a celestial body that is in orbit around the Sun and is not a star nor a satellite of a celestial body that is in, etc., etc. The definition of a planet makes reference to a planet. It's a recursive definition, which means this is a perfect example of the infinity of the universe. Seriously, how did this get passed? Am I the first person to have noticed this and to have come up with a solution? How about a planet is a celestial body that it's in orbit around the Sun and is not a star nor a satellite of such a body? There you are. So simple. But they didn't seem to think of this. Why not? It didn't take me long. And as we'll find out, there seem to be other things they didn't think of. But first, here's the vote being taken. Now, as you can see, not all the seats are taken, not by any means. One reason for this is that at the Congress, all votes are always taken on the last day of the event. And by then, a lot of attendees had already left. So instead of 2,700 attendees out of the IAU membership of 13,000, only 424 attended the vote, just 3.2% of the membership. So the decision was hardly representative of professional astronomers. As you can see, Jocelyn Bell Burnell, who discovered the first pulsars as a student, supported Pluto. So the draft definition suggested that the solar system's main objects going around the sun consisted of 12 planets split into two types of object, 8 main planets and 4 dwarf planets. The definition and its results may seem fairly straightforward, but they resulted in some questions. First, let's deal with Ceres. The point about Ceres is that with a diameter of 940 kilometers, Ceres has a mass that is sufficient for its gravity to pull it into a round shape. So it passes the first 2 criteria, but there are thousands of other asteroids, so it meets the criteria for a dwarf planet. The other controversy concerns Pluto and Charon, which, as I said, were included as a double planet. This caused some members to figuratively throw their hands in the air, saying, "We can't have that." So why was this proposed? Especially when the definition says a planet cannot be a satellite of a planet. Well, the answer is that Charon is not a satellite because it does not orbit Pluto. Let me explain. We say the moon goes around the Earth, but in fact, both the Earth and the moon rotate around a common center of gravity called a barycenter. We can see something similar to this if we look at an athlete throwing a hammer. As he spins faster and faster, the hammer swings further out. He rotates around the central point, not on it. And the Earth and Moon do something similar. In our case, Earth has 81 times the mass of the Moon. So you add 1 for the mass of the Moon onto the 81 and draw a line between the centers of the Earth and Moon, move out 1 unit, and you will find you are about 1,000 miles below the surface of the Earth. So it is accurate to say that the Moon goes around the Earth. And a similar situation is true for every other planet and moon in the solar system, with just one exception, Pluto and Charon. And here they are to scale by size and distance. But Pluto has only about 10 times the mass of Charon, as opposed to 81 times for the Earth and the Moon. So to find their barycenter, you add the ratio of their masses, 10 for Pluto, 1 for Charon, giving 11, draw a line between the center of each object, divide that by 11, and move out 1 unit. And you are in space. So, strictly speaking, Charon doesn't actually orbit Pluto. The barycenter is above the surface of Pluto, and both objects orbit around this point. But the IAU wouldn't have that. It was pointed out that our moon is moving away from Earth. We know this from the reflectors left on the moon by some of the Apollo missions. If we fire a laser to bounce off the reflectors, by measuring the time taken to go to the moon and back at the speed of light, we can calculate the distance very accurately. And because we've been doing this for over 55 years, we also know that the moon is slowly moving away from the Earth at a rate of about 3.8 centimeters per year. So since Apollo 11, it has moved 209 centimeters away from the Earth. But it was pointed out that eventually the moon will be so far away that the Earth-Moon barycenter will be above the surface of the Earth. Does that mean the moon will become a planet? Well, my reply was, why not? If its circumstances have changed, Why not change its label? We already do that with other things. For example, when a tadpole loses its tail and grows legs, we don't call it a tadpole anymore. We call it a frog or toad, even though it's the same animal. In any case, for that to happen will take over 4.2 billion years. So my response is, why do we wait until that happens in order to make a decision on the moon's status when that situation arises? But don't use this argument to make a decision about a situation that exists now. They refused to do that. But there's another related point. If Pluto and Charon had similar mass, then their barycenter would be halfway between them, and they'd be a double planet with no questions asked. So the actual question is, at what point does a planet and moon become a double planet? Should it be if the barycenter is more than 10,000 kilometers above the surface? Well, why not 5,000? Why not 2,853.7 kilometers above the surface? Any such value is an artificial measurement. It's a man-made value without any genuine reason. It makes much more sense to use their physical characteristics as a criteria. So, if the barycenter is below the surface of a body, it's a planet and a moon. If it's out in space, it's a double planet. Nothing man-made about that. No reliance on sizes or distances. And under that rule, Pluto and Charon are a double planet. We can actually see their movements showing this, both orbiting a point in space. But the IAU wouldn't accept this argument. Why not? Can't they understand logic? But not only was this rejected, but a vote was carried out on the IAU on the revised definition. Now, a team had worked on the draft version on and off for about 1.5 years. Other attendees thought they could come up with something better in about 4 days. And as school teachers will tell you, if you rush your work, you're likely to get sloppy results. Well, I've already come up with several issues, but there are other problems beyond those that I've already mentioned. A few days after the initial proposal, we had a new version based on the revised definition of a planet. And here, with Charon already ignored, Ceres, Pluto and Eris, designated dwarf planets, we had a solar system with 8 main planets and 3 dwarf planets. And in 2008, 2 additional objects were designated dwarf planets, Haumea and Makemake. Back in January of 2006, the New Horizons spacecraft was launched to Pluto. It was a triangular craft roughly the size and shape of a grand piano, carried 7 instruments, including 3 optical instruments. In 1992, Jet Propulsion Laboratory scientist Robert Starley had telephoned Pluto discoverer Clyde Tombaugh requesting permission to visit his planet. Tombaugh later remembered, "I told him he was welcome to it, although he's got to go one long, cold trip." Tombaugh died in 1997, and a portion of his ashes was carried on the spacecraft. Venetia Burney, or Mrs. Fair, as she became, died on 30th of April 2009 at her home in Epsom in Surrey at the age of 90. This picture shows Alan Stern, the principal investigator for New Horizons, presenting a plaque to Venetia in December 2006. New Horizons also carried a stamp originally issued in 1991 by the US Postal Service as one of a series on the planets. The Voyager spacecraft had been to all the outer planets except Pluto. New Horizons would finish the job. David Stern said, "Pluto may not have been explored when that stamp set came out, but we were going to conquer that." He added, "I want you to fly it as a sort of in-your-face thing." It was followed up by another commemorating New Horizons. Now, you may remember seeing bumper stickers years ago saying things like, "My other car is a Porsche." Well, I'm a mission supporter for New Horizons, and my name is on the spacecraft. So I created a sign which I put in the back window of my car, which said, "My other vehicle has gone to Pluto." Now, during 2015, the year of the Pluto flyby, I gave this presentation so many times that I also created an image of a t-shirt listing my tour dates. It was often suggested that I give this presentation at the next General Assembly of the IAU, which was due in August 2015. And I pointed out I'm not a member of the IAU, as I'm not a professional astronomer, although I added that I do partially make my living from astronomy. It was then suggested that I could be invited as a guest speaker. So I replied that would be very nice, especially as at the time the next event was to be held in Hawaii. Currently, the next one is 2027 from August 10th to 19th in Rome. And in August 2017, 2 years after the mission flew by Pluto, the IAU approved new names for features on Pluto, which included an area named after Clive Tombaugh and a crater named after Venetia Burney. Pluto's largest moon, Charon, was discovered in June 1978 by James Christie, and this is Pluto and Charon from the Hubble Space Telescope. He came up with the name Charon as a slightly changed pronunciation of the name of his wife, Charlene, plus on as in electron, positron, etc. He then found that Charon was not only a real name, but very appropriately the mythological boatman who ferried the souls of the dead across the river Styx to the underworld, which was the domain of Pluto. So Christie had his name, one that followed appropriate scientific naming rules while honouring his wife. Charlene liked to joke, "Many husbands promised their wives the moon, but mine delivered." In May 2005, 2 other moons were discovered from photos, and in June 2006, the IAU officially named these moons Nix, after the Greek goddess of the night, and Hydra, the 9-headed underworld serpent in Greek mythology, whose lair was the entrance to the underworld. I then sent an email to David Stern. I suggested that if a 4th moon of Pluto should ever be discovered, then an appropriate name would be Cerberus, after the 3-headed dog that guarded the entrance to the underworld. And if this should be followed by a 5th, then that could be named Styx, the river that formed the boundary of the underworld. Well, a 4th moon was indeed announced in July 2011 and a 5th in July 2012. A year later, the IAU announced their names as Kerberos, with a K rather than a C, and Styx. I can't really claim credit for the names, but it is nice that 2 further moons were discovered, and both the names that I suggested were actually used. New Horizons was launched in 2006, the 19th of January. This became, at the time, the fastest spacecraft to leave Earth at 36,400 miles an hour, over 10 miles per second. Even starting at this speed and with an additional gravity flyby of Jupiter to increase its speed, it still took 9.5 years to reach Pluto. This is a view it took of Pluto and Charon on the 29th of June 2015, just 15 days before closest encounter, but you can already see details on both objects. It flew past the planet on July 14th at a distance of just 12,500 kilometers. Its close-up view of Pluto showed amazing detail. But what was really amazing was that the largest shape on the surface just happens to have the appearance of Pluto. Now, I should make it quite clear that when this character was created, also in 1930, he was named after the planet and not the other way round. Here it is in enhanced colour, and here is a close-up of Charon in true colour. So here's Pluto with its moons to scale, a family portrait. Having flown past Pluto, New Horizons was able to take photos showing even more details as a result of shadows cast by the sun, and even a view of sunlight refracted around Pluto's atmosphere. Now, if Earth was round to the same degree as Ceres, it would look like this. Looks good enough. What about if our limit for roundness was 10%? It would be like this. Now, some people might think that's a bit much. How about 5% as a limit? Rather than the Earth's actual value of just 1/3 of 1%. But what about Jupiter? Would it fit within a limit of 5%? Unfortunately not, because Jupiter does not have a solid surface and it rotates not in 24 hours but just under 11 hours. So like an ice skater spinning around, its equator is flung outwards and its equatorial and polar distances are different by 6.5%. So if our limit was 5%, Jupiter would not qualify as round. What about the other criteria? How about the third, to have cleared the neighbourhood around its orbit? The idea was that with large objects, their gravity would clear other objects out of the way. But if we look at Jupiter's orbit, we can see what they completely overlooked is that an object with high gravity will attract objects into its orbit. In the case of Jupiter, there are two main groups of objects, shown here in green, 60 degrees ahead and 60 degrees behind Jupiter in its orbits. And because of their individual names, they're known as the Trojan and Greek asteroids. More than 1 million of these larger than 1 kilometre are thought to exist, of which more than 7,000 are currently catalogued. An object 1 kilometre across, orbiting Earth at the distance of the Moon, would be 4 times the limit of what can be seen from the Earth. So this means that more than any other body in the solar system, Jupiter grossly fails the criteria of clearing its orbit. So Jupiter, the largest object in the solar system other than the Sun, fails the third criteria and despite being 10 times the width of the Earth, it actually falls within the definition of a dwarf planet. Now, what does that tell us? That Jupiter is not a planet? No, of course not. It certainly is a planet. What it tells us is that this is a terrible definition. Unfortunately, it doesn't stop there. Let's come back to barycenters. Each planet has a barycenter with the Sun. It's below the surface of the Sun, usually close to the center of the Sun. As a result, it is accurate to say that the planets orbit the Sun, with one exception. Again, because of the high mass of Jupiter and compared with its huge distance from the Sun, the Sun-Jupiter barycenter is above the surface of the Sun, almost 47,000 kilometers above the Sun's surface, out in space. So Jupiter does not orbit the Sun. Both objects orbit that point. And as a result, from a distance, the Sun will be seen to wobble from side to side. Now, we have actually seen this happening with other stars, and so we can deduce that they are being orbited by large planets. As far as this discussion is concerned, the important thing is that Jupiter does not orbit the Sun. That's another reason it's not a planet, as it fails the very first criteria. That means in total it fails all three. And if that doesn't prove it's a poor definition, I don't know what does. Even if we ignore this inconvenient truth, there are still other problems with the definition. What about the question of a planet having cleared the neighbourhood of its orbit? This view includes all the 5 dwarf planets. But if we look at the asteroids that are mostly between Jupiter and Mars, shown here in white, not all of them are. The orbits of some go further out, even crossing the orbit of Jupiter, making another reason why Jupiter has not cleared its orbit. Some go inwards, cross the orbit of Mars, so a similar argument can be made there. And a fair number even cross the orbits of Earth and Venus. In fact, the ones marked in red on this diagram are referred to as near-Earth objects, which number over 37,000. Some of them come so close that they hit us. Although most of them are quite small, some are much larger, such as the one that did so 10,000 years ago and created Meteor Crater in Arizona. But there are over 200 major impact sites around the Earth. So it's obvious that Earth has not cleared its orbit and therefore does not qualify as a planet, but as a dwarf planet. We're actually now getting into another subject. If you want to know more about the threat of near-Earth asteroids, you need to book my little number entitled "We're All Going to Die." So where does that leave us? First, let's have a look at the new solar system as per the first proposal to the IAU, but also including the 2 additional dwarf planets designated since then. And we have Mercury, Venus, Earth, Mars, Ceres, Jupiter, Saturn, Uranus, Neptune, Pluto, Charon, Haumea, Makemake and Eris. We need a new mnemonic, so I came up with: my very Epicurean mother creates jam sandwiches using newly purchased chunky Hartley's marmalade. Excellent. Well, take it or leave it. With the official solar system consisting of 8 major planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune, and most school books will now say that there are 8 planets in the solar system, even though this is not correct. My offering for a mnemonic, seeing as I'm not in favour of this, my version evidently might just suggest universal nonsense. But if we restart with the full solar system and remove the official 5 dwarf planets, we know from the definition that Jupiter fails the third criteria, so it must also be a dwarf planet. We have to remove that as well. And as many asteroids cross the orbit of Earth, then that has to go. And they also cross the orbit of Mars, and as we've seen, Venus. And as many people have pointed out, if Neptune had cleared its orbit, Pluto wouldn't be there. So we have to lose that as well. That leaves us with 3 main planets. So we need a new mnemonic. My so unexpected. Because obviously this is not what the IAU expected or intended, but it's the result of a particularly bad definition. So, considering the controversy that has resulted, I came up with another mnemonic for this group. My very eccentric mother causes, justly, some uncertainty now planets have made exceptions. But the question remains, is Pluto a planet? It was designated as a dwarf planet, and the IAU said a dwarf planet is not a planet. Well, not only did many members of the General Assembly not agree with this, but so did members of the public, and they showed it. There were also cartoons. I rather like this one. And there are t-shirts. Now, as an update, I wonder how many of you know that a 6th dwarf planet was officially designated, but not until 9 years after the term was first put forward. In July 2015, this shows its movement over a period of 3 hours. It's nearly 700 kilometers in size and referred to as 2015 RR245. And although it was discovered back in 2015, it still hasn't been given an official name. What has the IAU been doing for the last 10 years? It means we can't update the planet list or the mnemonic, though it does mean we now have a grand total of 14 objects. But why have no other dwarf planets been designated? There's an obvious question. What is a dwarf planet? Well, what's this? Well, you might say it's a goat, but is it? Because it's actually a Nigerian dwarf goat. So because it's a dwarf goat, does that mean it's not a goat? Of course it is. And what's this? This is a frog. This is a seahorse. This is a spider. This is a beech tree. This is a hamster, a rabbit, a honeybee, a whale, and a tiger. And the variety of bananas that is the most widely sold all around the world are dwarf bananas. And guess what? They are bananas, despite what the IAU might have you believe. Now here's a scene from the classic film by Terry Gilliam, Time Bandits. which features several dwarf actors, including this one, who also played the robot R2-D2 in the Star Wars films. He was Kenny Baker. But basically, despite being a dwarf human, he was still a human. Yet we're told that a dwarf planet is not a planet. Why is that? Well, let's suppose that astronomy is special and doesn't need to be consistent with all other sciences, and it doesn't need to follow their rules. So if astronomy says an object is a dwarf planet, then it isn't actually a planet. Well, even if astronomy does not need to be consistent with every other science, it does need to be consistent with itself and follow its own rules. So this is obviously a star, but actually it's our star, the Sun, and more than that, it's a type G2 yellow dwarf star. Does that mean it isn't really a star at all? No, it doesn't. It is a star. There is not a single astronomer, amateur or professional, who will say it's not a star. All dwarf stars are actually stars. This is accepted within astronomy as a science. And what about this? This is a dwarf galaxy, and so is this, and this. So if, according to astronomy, a dwarf star is a star and a dwarf galaxy is a galaxy, it's simple and obvious. A dwarf planet is a planet. It's just a small one. After all, that's what the term dwarf planet means. If the IAU didn't want these objects to be known as planets, they shouldn't have labelled them as planets. So with regard to the main question, the answer, thanks to the IAU definition and what it actually means, is clearly yes. Pluto is a planet. Thank you very much.
That was very thought-provoking, Jerry. Thank you very much for a wonderful talk, and you've probably seeded a lot of thoughts into our audience. We don't have any mechanisms for doing polls, I'm afraid, but nevertheless. Nevertheless, extremely thought-provoking. So thank you so much for bringing our what are we, our fifth National Astronomy Week session this week to a close. We've had a wonderful hour of live streaming and a great talk, which will make us go away and have a think, most probably. So thanks very much to Jerry. As I mentioned earlier, thanks to everybody earlier for their live streams, and indeed the people behind the scenes. So this is us almost signing off halfway through National Astronomy Week. Stay tuned for the next few days, next few nights. Tomorrow's theme is star clusters. So let's wait and see what that will bring us. Hopefully some more wonderful live streams, and yeah, more to come. So do tune in the rest of the week, and thank you so much for staying with us today. Much appreciated, and I think we will sign off there. Jerry.
I should